Assalamualaikum and hi everyone. My name is Muhammad Amirul Amin bin Muhammad Masrum. My supervisor is Sir Jamil bin Muhammad Sapari. I would like to present to all of you my review report entitled A Review of Synthesis Polyurethane with Different Surfactants. To give overview what I will present in this video, it will starting with the introduction, followed by synthesis of polyurethane, synthesis polyurethane with a different surfactant, and lastly conclusion and recommendation. In this part, I want to highlight two main components which are polyurethane and surfactant. Based on my research, relationship between these two components provides interesting studies to be learned, and I will explain detail in next slides. Surfactant is mixed with other chemicals such as polyol, catalysts and blowing agents. The following reaction is by addition of diisocyanate. The products formed were the rigid polyurethane, flexible polyurethane, and polyurethane foam. The function of addition surfactant. First, it will lessen formation of bubbles during forming process of polyurethane. Next, it also helps to support in controlling the growth of bubbles during synthesis and the morphology of the foam cell, as well as reduce surface tension. Apart from that, the objective in this study to elaborate different methods to form polyurethane and the way of polyol and isocyanate being synthesized. Second, to study effect of addition of surfactant in polyurethane synthesis by using anionic, cationic, non-ionic, amphoteric, and silicon surfactants. According to Basby et al. 2020, polyurethane are synthesized by copolymerization di or polyisocyanate with polynucleophile, which prefer active hydrogen-containing moieties to make polymer backbone. Gamma et al. 2018 stated Otto-Bayer created polyurethane by polyester diol with diisocyanate. The process known as step polymerization, reaction of 1,6-diisocyanato-hexane and 1,4-butanediol are the first chemical introduced to form polyurethane by Otto-Bayer and his co-workers. Now, we will proceed to discuss about methods to produce polyurethane. Firstly, we will discuss about the one-shot polyurethane. Abdul and Rahman et al. 2018 stated the polymer is formed via simultaneous reaction of polyol, polyisocyanate and chain extender in the one-shot process. It is extremely exothermic, causing scorching and flames. The advantages is proceed at low temperatures, low viscosity, and commonly used in rigid and flexible polyurethane foam and also in elastomers. Next is pre-polymer polyurethane. Based on Fernando et al. 2016, it is commonly used in injectable two-component system to improve handling properties or reduce toxicity. It uses less monomeric isocyanate, use smaller temperature and more compatible than one-shot method, but it is highly viscosity and high mix ratio, lead to mixing and metering issues. For quasi-pre-polymer method, it is an intermediate between monomeric isocyanate and a complete pre-polymer. Based on Barbara Susana Gregory Valdez et al. 2015, it uses simple machine design and operation, not complicated and low temperature. The pre-polymerization process uses quasi-prepolymers method. We moving on to synthesis polyol. It is stated the initiator demonstrate good result during reaction in polyol process. What is initiator? It is a chemical that combines with monomer to generate an intermediate product capable of joining a large number of additional monomers to build a polymeric complex. As a result, many active sites will form, and when the surfactant added, the reaction will produce the desired polymer. Figure below shows the reaction to produce polyether polyol types. Toluene diamine act as initiator in that during initiation steps. For isocyanate, as we know, the phosgene has long been used as an organic synthesis reagent to make isocyanate, which are employed in production of polyurethane. Even though phosgene is not volatile, it is very poisonous and reactive. Apart from that, non-isocyanate-based polyurethane have been developed with more environmental safety. The method that can be done by the cyclic carbonate pathway, transurethanization, ring opening polymerization, and the rearrangement. Now, we proceed with synthesis polyurethane with different surfactant. We will start with classification of surfactants. Based on Takamura and James 2015, non-ionic is the water solubility of hydrophilic heads which derive from highly polar groups such as polyoxyethylene. For anionic, according to Martins and Diaz 2019, the hydrophilic head consists of negative charge group, for example, carboxyl, sulfonate, sulfate or phosphate. He et al. 2021 said for cationic, the hydrophilic heads mostly in positive charge. Example, quaternary ammonium halides. Pfeiffer et al. 2021 stated amphoteric is molecules potentially exhibit both positive and negative charge, such as sulfobetanes. Last but not least, silicon is hydrophobic tail by replacing several carbon atoms by one silicon atom or one dimethyl siloxane group based on Gloss et al. 2020. Next, we will elaborate the addition of surfactant in polyurethane synthesis. We will go on synthesis polyurethane with non-ionic first. For non-ionic surfactant, I have stated three types which are pluronic, PEG mono, and triton S100. We will discuss first for pluronic surfactant. Based on Brusky et al. 2017, pluronic is known as tri-block copolymers of polyethylene oxide and polypropylene oxide. It also known as polysomer. It is stated polysomer shows thermoresponsiveness, high ability to solubilize medicines, excellent drug release, and lack of toxicity. This pluronic surfactant act as source segment in synthesis and characterization of metformin, pluronic-based polyurethane for controlled drug delivery. Now we continue with PEG mono and triton S100. PEG mono is polyethylene glycol monooleate while triton S100 is polyoxyethylene octyl phenyl ether 100. Based on Samsuri and Mat Jamil 2020, both surfactants show significant study in polymer nanocomposite. For PEG monosurfactant, it can modify cellulose nanocrystal and for preparation cellulose nanocrystal polylactic acid, while for triton S100, used to change inorganic nanofillers such as modified carbon nanotubes to make carbon nanotube polybenzooxazine nanocomposites. Figure below shows chemical structure of non-ionic surfactant. For A, it is triton X100, B is pluronic, and C is PEG mono surfactant. Next is synthesis polyurethane with an ionic surfactant. In these types, I have list SDS and SDBS surfactant. We will go first with SDS surfactant. SDS, or known as sodium dodecyl sulfate, made up of an anionic organosulfate connected to sulfate group. It demonstrates emulsifying, solubilizing, highly forming, and effective cleaning agent based on Wolowitz and Stazak 2020. Based on Daliwa et al. 2020, the use of SDS surfactants in the production of soil-based polyurethane foam demonstrate addition of sodium chloride and SDS surfactant in foam boosted surface viscoelasticity and foam stability. For SDBS, or known as sodium dodecyl benzene sulfate, based on Srivastawa et al. 2017, it stated SDBS is linear alkyl benzene sulfonate having a 12 carbon alkyl chain. In terms of foam stability, the usage of SDBS produced adsorbed bubbles with outstanding characteristics. According to Salami et al. 2020, in polyurethane synthesis research, the use of SDBS surfactant have displayed good behavior towards antimicrobial activities. Figure below shows chemical structure of an ionic surfactant. For A, it is SDS, while B is SDBS surfactant. Moving on to synthesis polyurethane with cationic surfactant, I will go on to quaternary ammonium surfactants. Based on Anici et al. 2021, high surface activity of quaternary ammonium surfactant with outstanding adsorptive and bacterial qualities have been widely used in detergent emulsification, phase transfer catalysis, material synthesis, separation, metal corrosion inhibitors, and sterilizing. Based on Grigoras 2021, in synthesis antibacterial polyurethane, the use of quaternary ammonium salts such as BAC to boost polyurethane bioactivity and performance. CTAC is known as cetyl trimethyl ammonium chloride, while CTAB is cetyl trimethyl ammonium bromide. Based on Liu et al. 2020, CTAC has been utilized as a bactericide as well as high temperature oil in water emulsifier, but CTAC rarely been used in polyurethane synthesis. Cheung et al. 2013 explained the synthesis of PU polyurethane copolymer linked with metal ion indicator for selective cationic surfactant detection in aqueous solution that shows a good properties. Cationic CTAB surfactant solution causes polyurethane to react immediately, displaying the specific color for its indication. Figure below shows cationic surfactants. For A, it is quaternary ammonium. B, it is CTAC, while C is CTAB surfactant. Next, we will discuss about synthesis polyurethane with amphoteric surfactant. I have stated 4 types of it, which are APAO, or known as alkyl amidopropylamine N oxide, AO, or alkyl dimethylamine N oxide, BT, or alkyl betaine, and lastly APB, or known as alkyl amidopropylbetaine. Based on Coy et al. 2007, amphoteric surfactants such as betaine have strong detergency, great forming capacity, and gentle on skin. Alkyl betaine shows stronger hydrolytic stability than alkyl amidobetanes. Based on S1 et al. 2021, the use of an amphoteric polyurethane retaining agent can lower lather's negative charge, increase its zeta potential and isoelectronic, and improve absorption rate of anionic with finishing products. Figure below shows chemical structure of amphoteric surfactant. For A, it is AO, B is APAO, C is BT, and D is APB surfactant. Last surfactant I want to explain is silicon surfactant. Polydimethylsiloxane backbone and polyethylene oxide copropylene oxide random copolymer graphs make up silicon surfactant. Based on et al. 2021, the use of silicon surfactant in rigid polyurethane enhanced the performance of polyurethane properties. According to Bafrani et al. 2018, in the synthesis of open self-flexible polyurethane foam, addition of silicon surfactant gives a new development in polymer study. Figure below show the chemical structure of PDMS surfactant. What can I conclude from this review? Firstly, polyurethane is the most demanding form of polymer in today's world based on S1 et al. 2021. Second, the one-shot mixing technique and the pre-polymer method are two well-known reactions in the development of polyurethane. Third, among other surfactants discussed in this review, surfactant with a higher silicon surfactant shows lower surface tension and help increase number of air bubbles introduced during mixing in synthesis polyurethane. For the recommendation part, I hope more studies on other types of material besides surfactant can be used in development of polyurethane. Second, in terms of reducing surface tension in polyurethane, others necessary additives can be used that have same properties like silicon surfactant. It is due to some of surfactant are produced using hazardous chemicals which could affect environment.